me fly. I can't resist, 'cause you have got a hold on me. And all these thoughts, when you are here, you light up the dark sides. To live in the night shine, you take my life and light every side. You fade the dark inside. The living light shines.
So, yep. So we having. So yeah, this test screen. So let's see. I mean, yeah, let's see why. We're looking at strings. Now let's check why this test is failing. So it's compose me, yeah. And first we don't need this. Compose me takes a string slice and returns a string. What it does is here we're adding we are taking the string slice, converting it to string, and calling the add. The add traits. I think yeah, it's supposed to return. It's supposed to add worlds to it. Yeah, so give a space. I think that's probably the problem. Yep, I fixed it. So we can go to the next one. String 4. String 4 also works. What? Did you solve this one? Yeah, we did yesterday, I think. Yeah. Okay, and now what's next? Okay. So this should be modules. Yep. Yeah, let's try to solve modules. Well, by the way, I'm trying a different layout today for the stream, and what I'm doing is we have, I mean, I switched to where we have the video, and also I try to put the chat here. I don't know if it's gonna work. I mean, I don't know how it shows, if it shows well enough, but I don't think so actually. The chat is very much, it's very small. Yeah. It's probably more helpful that it's there, from what I see. So I'm probably going to remove the chat. It's a browser window that just shows up there, pops up there. Actually, maybe I can customize the, you know what, I'm going to leave it like that today. Then we see how it does in the end, right? That's what I'm going to do. Yeah, I'll leave the browser window like that. Yeah, we determine how it is afterwards. Yeah. Okay, let's get back to what we're doing. So we need to look at modules. Yeah. Oh yeah, I think we can do that from here. Yeah, module system. Okay, I think I need to do this.
Don't look behind your back.
So what about
when the world is
modules?
getting darker? I have a dream where love's the
I'm just gonna go
only
through it.
side. So take my hand,
I can just create
join
some
the army
modules.
of the shadows. Going harder, we are more than numbers, standing in this air.
So we have library crates and binary crates. Library crates just don't have main function. They don't compile into executable. And for us to create a new crate, we do like so. If we want to create a binary crate, I think we have to say, sorry, if we want to create a library crate, we add the lib flag. I think I said that somewhere before, but yeah, we can look at that. So, just 1 second, I'll be right back. Right. Okay.
Find someone new, baby, but you know I never will. No, so I choke you down just like a pill.
So we use the use keyword to bring a path into scope, and the pub keyword to make it public. Hash keyword. Yeah, we discussed that after. Yeah. Modules. So when compiling a program, compiler first looks in the crate root. Usually it's src lib rs or main rs for binary crate. This is how we declare a module. And I need to first look for it within the declaration, like so, like we do for tests when you want to that's unit test actually, or it will look in src name of the module rs or src module rs. Okay. In any other file than the crate root, we can declare submodules. For example, we can declare mod vegetable in src garden. Yeah. Okay. I think that one is understood. And then for paths,
feel the waves cut through me, hypnotized by the sounds I'm breathing in. Hold tight, chemicals collide. Hold tight, hold tight, hold tight. Dripping lights paint the
the code within the module is private from spared by default. To make it public, we use the pub mode. So this is how. So inside of main.rs, we are going to declare that there is a garden module. Yep, like so. And then inside of garden module, which is in garden.rs, we're going to declare that there is a vegetables module here. And then that's it actually. Yeah. And we're using pub so we can reference them. Yeah. This is how to create a library crate. And so. That's for referencing to an item. The path can take two forms. The absolute path, but which will start from the create root. And then you do create, and then you double colon. Or you can use a relative path, which starts from the current module. And it is self or super. Self super. Or identify the current module. Out of that loop, so you can do absolute referencing. You can start from the root, just the RS, right front of level. And then relative path, you can just start from the current module. You can actually use super. Himself. Okay. Exposing paths with the pub keyword. The module tree should be defined in leave.rs. Any public items can be used in the binary crate by starting paths with the name of the package. The binary crate becomes the user of the library crate. Yeah, just like this now. Okay. With the use keyword, we give us scope. Yeah, that's just like we do import. Yeah, can be anywhere. Doesn't matter. We exporting names with pump use. Pump use this. We bring a name to scope with the use keyword. The name is private to scope. To enable the code to be outside our scope, to refer to that name as if it had been defined, we will probably use re-exporting. Okay. Yeah, external packages. Just like in cargo terminal file. Now we can use it. then let's compare ordering. How does ordering work again, by the way? I don't remember this one. Can use some salty or something? I don't remember. Yeah, separating modules into different files. This is all the file. Okay, I think we're done with that part. So let's go to our program now. I don't know if this is actually clear. Let me try to make it a bit. Does it work? No. Let's get it back. Probably like so is better. I don't know, it feels a bit like it would be difficult to read. What was if it's going to affect, right? Yeah, I can do that. Probably it's better like so. Yeah. 25, but it's going to be easier to read. And then I can drag this in a bit. Yeah. All right. I think it's better. All right, let's try to fix this one. It's getting dull in here. I'm not sure why this thing stops, to be honest. Like, I need to download. I tried downloading the app, but it was failing for some weird reason. Yep. Okay. So we fix compiler error by calling a private function. We have sausage factory, and it says we shouldn't let anybody outside of this module see this. This is the module. We have a get secret recipe, which is private by default. And we also have a make sausage function, which calls get secret recipe. Yeah, and then print sausage. Okay, what do we want to do? Fix compiler error about calling the private function. Oh yeah, so make sausage is private. So we need to be able to make it public. So first of all, the function has to be public. Yeah. That's it. The next one. So it says we should add the following two use statements after fixing them. The we have a module, delicious snacks, and inside we have a sub-module, fruits. We have two sub-modules, fruits and vegetables. We declare constant, yeah, and we are trying to use the fruits module. Try to use fruit. Okay, and veggie as well. So I guess we can do that's fruit. Okay. As veggie. Okay. But so they are both public, but you cannot use them even though they are public, because the module itself is private, right? The cost. No, I think that's not why. I think what we should need. Wait, hold on. I think what we need is export. So we need a pub use. Yep. The pub use here as well. So what is fruit, veggie? What is it? Fruit not found in delicious snacks. Delicious snacks. Fruit. Oh yeah. What is it? Pub use fruit, pear as fruit, as veggie. Wait. Are you sure this is not already fixed? Wait. It is. Is this thing just slow? It is slow. Let's go to the next one. So, so it says we should bring system time and the Unix epoch from the STD time module into scope. But on start point, if you can do it in one line, of course we can. So STD time. I think we can do. Should bring system time, Unix epoch. That's it. You see, I'm not sure why this thing is always like this. I don't have to always rerun this. Oh yeah, okay, so it did it this time. So we're done with modules. Oh, sorry. We're done with modules. So now we're on hash map. I think this is in collection. Yep, a hash map. It wants us to read about further information stored in associated values. Okay. So the assumption is that we already did storing of values in vectors. Yeah, I think we saw vectors earlier, so let's just common collections. Yeah, I think we already did this before. So that's why it's telling us about just going straight to hash maps. Okay, so let's do this. Okay. So hash map will over key and value types will store keys of type K to values of type V using the hashing function. It determines how we place the values in memory. How to create a hash map is hash map new associated function. Like vectors, hash maps store their data on the heap. Unlike vectors, hash maps are homogeneous, of course. How to access values in the hash map? We can use the get, and get takes a reference to the key type, right? Why is this copied? Because it's going to give you. Okay, let's try. So let's say we wanted to create a hash map. Let map be hash map view. Yeah, it cannot resolve it, so we need to bring it into scope. Okay. I'll call insert. Yeah, take the mutable reference to self, and then the key and the value. And for this one, I mean, the type will be known when we provide the first value. Yeah. So if you say, no, let's say I'm going to use the literal 3, for example 3. Yep, then we say reference with string slice and I32 in this case. Right? Oh yeah, so you cannot, it's mutable, so cannot borrow up as mutable. Yeah, because inside takes a mutable reference, so we have to say mute. So that's which inside values to the map. Yep, then because it's iterable, we can click on it. And I guess we can, so to access the values here, map, but we have get, right? Yeah, get done as an option. So it takes reference to self, yeah, and then okay, it has the reference to the value corresponding to the key. The value corresponding to the key. Okay, the key may be any borrowed form of the map's key type. But what is key there? Okay, key high. Yes. So this would be green. This is given an option that has a reference, right? Yep. Option that is a reference to an identity type. Yeah, so we need to print the value from there, right? So yeah, I can use this short form, right? How does that even work here? I think it's called the short circuit operator. I can handle the error. What is that again? Expector. And so where there's no value there, so option is some or none. Yeah. So this is not exactly going to give me an error. It's not an error, but let's copy it to not an option as a reference to an actual type by copying content. No, that's not what I want. Is that not what I want? I want to get the actual value from there easily. I have an option. Okay, I would say maybe expect that it should have a value, certainly. I think we would want to convert this from an option to maybe a result. Almost okay, or yep. It transforms the option into a result. That is probably what I want. Then I can try to handle the error value. And then I can yep. Is it not? No. Oh yeah, okay. Just like so. This is it. Oh yeah, but because expect is going to try to give you the expect is gonna return the content OK value. Yep. Yep. Okay. Oh, come on. What is the problem here? It says it's expected one argument. Expected one argument found 0. Okay, or what does it take? Okay. Wait. Yeah, it takes the error. I think I can pass an error to it. What is the... So basically this is like... there's a number... numeric here. Can I pass I don't think what error comes from what else do I have for this actually? Maybe I have... Can I just simply unwrap this thing and move on? Yeah, why not? unwrap. Yeah, if I do unwrap, then I don't need all of this then. Yeah. I mean, we're just trying to see how this works. Yeah, it has a value of 7. All right. So what I did here is copied unwrap or, then they put an initial value, which makes sense actually. Where are you? Oh, come on. Yep. Yeah, because when you're dealing with hash maps, it's best to, because that's mostly what you want to do. You want to say, if you don't find this, then set the initial value, right? Or default value, yeah. Makes sense. Okay, yeah. We didn't need to do the trying to convert that to a result and the rest, because I think for a hash map, that's really not the kind of thing you want to do. Yeah. But anyway, we're just playing around with the APIs and see what's available to us. Then you can also iterate over the key and the value. Yeah. Ownership. Values are copied into the map, into the hash map for those string. Values are moved. So if I have this and this, mute. So if I try field name and field value are invalid at this point because they've been moved to the hash map. Updating the hash map. Yeah, you simply insert overwriting the value. That's what we saw just now in our piece of code. So adding the key only if it's present. So we call entry. Entry. Entry API. So yeah, the entry API, it allows for complex methods for getting, setting, updating. So you call entry. I mean, how does the entry exactly work? Where is it? Yeah, method entry. So it takes immutable reference to self and a key. Returns an entry that has a lifetime, a key value, and what's the last one? So you have a hash map letters, and then for ch in, you convert this to characters, like get charts from this. Now you do letters.entry. So try to get every entry here, and then you pass the key, which is each one of these. You call and modify, and then which is doing a mapping function here, and then it mutates the values inside there. So it takes what it finds there, and it's dereferences it. And modify. Why does it add one to this? Okay, yeah, it just, I mean, I need to see what this returns. That is on entry. And modify, provides. So, okay, it just takes a function actually. Yep. Returns yourself, provides an in-place mutable access to an occupied entry before any potential inserts into the map. So you take the key, you call and modify, and then you pass a function to it, which is take the value if it's found. I mean, if the entry is found, and then you execute this. So you oh yes, because this hash map is string slice and a numeric type here. So entry is going to return the entry there, right? So it was key you passed, but it's going to give you back an entry, which in this case is the U32 value here. You dereference it, you add one to it. If you don't find that, you insert 42. So I have a map. A hash map, sorry. How do we set the initial value of a hash map? Is there anything else other than new there? just new. Default values. I mean, maybe you don't. Yeah, hash map from. Yep. Initialize from an array. Okay, so that's what you do. So from an array. Okay. Value converts to this type from the input type. So you can pass an array, you can pass a vector, whatever. So I can do pizza. And what do we see there now? Yeah, okay. Let's say it's like 10 pizzas. Okay, then we want to call entry, check missing reference, and then we take a key. Burger. So again, entry returns us. Yep. It's an entry that has a string slice and the value. Yep. So I32. Burger. It's a function now. It's a reference, so we can do this. Just add 2, for example. Yeah. Let's set a default value 5. What do we get? Let's reference to this. What is this here? This might have expected unit type found integer. How do you mean? Expected unit type found integer. Oh, is it because it needs to return the value? I mean, maybe the syntax is not correct, or do we need to do? We don't need to do that, do we? No. No, we don't need that. So what is the issue here? I don't know what the issue is. So what? How does unmodify look again? Again, we go back to the entry API. Unmodify. Is it? What is different? Okay, the only difference here is that we are doing this the yeah. Okay, but then why shouldn't we do this? By the way, I need to change the formatting for so it doesn't go back. But anyway, that's result. Result is 5 because we don't have burger there. We can also print what we have in the map at the end, right? So for key value in, give me a reference to the map. Then why is the reference to? Okay. Yeah, burger 5, pizza 10. Okay. So there's the we saw the or insert method. As used to set a default. Is it for the default one again? Let's see. No, wait. Yeah, all insert sets a default value. Yeah, that's correct. Yeah, technically it's much cleaner. Our insert method is defined to return a mutable reference to the value for the corresponding entry key if that key exists, and if not, it inserts the parameter as the new value. Yeah, updating the old value. I mean, and update it based on the old value. Is there not another way of doing this? Wait, why can't I just use and modify? That's a function. I don't need to use a for loop, right? How did they say this? We need to do a count, that's all right. Hmm. Hmm. Okay. So if I do, I convert this to chars. I want to convert this into an array. Well, I can already I do to into, is it? Yep, I can do into. Wait. Yeah, I can do into, and I can say that this, I can say this is an array. I have to specify the length and, or I can say it's a vector. Then it's a vector of type I think yeah, why not? Trade bound is not satisfied. Okay. Why can you not automatically do this? Okay. I mean, I just don't want to make it verbose. If not, we can say
No, wait. Should be an easy way for us to do this. I want to know why I cannot do that. Oh, do I need to? Wait, do I need to say? No, I don't need to specify that. That is the. No, I can do that actually. Right? Where did I see that again? Okay, this is the trait. What is the into trait? You have to call the into method, right? No, wait, we don't need this to see this. Usually inferred from the input examples. Right, you have to say this is a thread bound. You say to vec on it. So can I say we don't have to anything on this? It's probably not implemented on that. Or do I? Is it that I need to no? Collect. Come on. You can also do. Yeah, but you have to specify the length of this first, and that's where you don't want to do the array one. But you can just do a collect to convert it to a vector. Yep. Okay. No, I didn't think of that actually earlier. I think we need to specify the vector and the type because it doesn't know how to collect it. Is it not? What's the issue? A value of type can be used moderator over elements of char. I guess after collecting these, okay. Yeah. So after collecting these, you can wait. This is not a okay. Wait. You have the values here. We can map these. Cannot be built from. Is this the problem? Because that was the problem. In this case, do I still need this? Yeah, I still need it because it still doesn't know how to do it. Hey, let map vec-char like that, okay? So that this is not necessary. Okay. Okay. The vector of characters here. Yeah. Earlier I tried to use I tried to do into an output. Yeah. I tried to do into and like the chars. Okay, so I'm thinking why this doesn't work. It says the trade bound vectors is not satisfied. So there's no from implementation for this. That's why it doesn't work. Why would that be? Actually, okay, you cannot go from. I mean, I guess that's just. I would expect that to be available anyway. Okay. Yeah, so back to what I was doing before we digressed. So we have this and we wanted to, I think I was looking for a way to just go from this straight to a hash map, right? Immediately, and then count
the word occurrence here.
Actually, that's not what I want to do here. I think I want to split this as well before I do chars. What do I have for that? Split white space, I think. Return string slices that are subslices of the original string separated by an amount of white space. A few words would have a few words. Okay, this is what I need. Okay. The return type, yeah. What does this return again? It returns split white space an iterator itself. Is that yeah, it's an iterator. Okay, so then yeah, then I can use that directly, right? Yep. So if where we have is this, yeah, then we can do it, we can convert this directly. So we have an iterator that has the that contains characters of this the strings here. So hello world, wonderful world, and now I want to put that into a hash map. We can create a hash map directly from that. So I want to create a hash map and put the values there. I guess we can do that immediately, right? But first we can collect the values. We should be able to collect the values. Why hash map? Yeah, because I want to count. Because I want to. So we're looking at hash map, and I want to count what we have, like the occurrences of the strings, right? So basically we have string literal, like so. I want to process it and then count. So I want to go straight from here without using a for loop. So this is not this. What would this give us actually? Can we build from an iterator? So after we split white space, what's the type that we would get if we don't do anything here? Just annotations needed. Yeah, strings slice. Okay. So now that we have this, we can. Oh, this is not even a map. It's I'll call it strings, and then this would be. Now we need to put this. We can go over strings. Actually, we should do b hash map from, and then we give it the value. So we give it strings vector. It should be able to give us a hash map from here. But why does it behave like it doesn't know? The trade bound hash map. So you can convert from this. Is it because this is string slice? Yeah, okay, this can be built. Then, so why can't we go from this? Can we do something here? If this were actual string type, shouldn't complain, right? Map. Can we do you need to iterate over vec. Okay. I want to convert strings. I want to turn strings into a hash map by using the hash map from function for slice in slices. Yes, I want to avoid using the for loop. So I want to do it the functional way. I mean, I can do that, but I'm just thinking about how to use. I already have a collection, so yeah, maybe I can work with it directly there. So that's what I was trying. I'm trying to do actually. So with this, what about this? Nah, doesn't do that. Okay. So types collect cannot be built from m. You cannot call collect. Is it because okay? Iter. So we'll call iter on what? Which one? Yeah. So this does it first of all. Anyway, this is I don't like this here, but I want to see if I can. I still cannot go from strings to a hash map. Ah, wait. Yes. Yeah, okay. You can't do that because actually, yeah, there's no way. You need key and value, right? And then that's not what you have here. Yeah, that makes sense actually. So, um, so there was actually no need to do what I just did. I don't think the link that you sent now would be clickable, would it? It doesn't look like it is. Oh, I can. Let's try. No, it's not the full thing. Let me try to copy everything. So from implementation. Yeah. So it's K V. Yeah. N. I'm guessing this will be size, yeah. For hash map. Yeah, exactly. So that's what I was also just looking at. So we definitely have to for us to be able to go from strings, then this has to then be key and value, yeah. So I need the but if I wanted to make a hash map of this, Okay, I guess I cannot use from then. Okay. So we just use new. Yep. And then we go over, iterate over strings, and when we find values there, yeah, that's what you were saying, that we could iterate over it, right? Yeah, but because we want to, actually we are not, it probably makes sense to just use a for loop, because we are going to be um, making changes or side effects or something with it. Okay, for item in strings, then we want to check the map whether a value already exists. If not, we insert it or increment the count. So for entry, and then the key, all our key be here to be item, right? Yeah. How is that even? Yeah, it's just item dot. So we're looking at hello right now, the first item in strings. I think we can use and modify. Yeah, so basically you found, yeah, we need to give this a type first of all, because it's not yet known. Sorry. This would be, hey Justice Flugo, hello again. We can do this, yeah. And I think for this one we don't even need this to be full string anymore. We can just do what we had before. This is not necessary. What? I said they're gonna be built from from an iterator over elements of type. Oh, you're eating dinner. Yeah. Oh, yeah, I 32. Yeah, okay. Yeah, I think I meant to do this. Yeah. Okay. Yeah. So we have this now, and we have our map, and then we want to go over the values in the string, find an entry if it does exist here. Yeah, so if we get entry and there is an item there, what we want to do is to update or rather insert a value into the hash map. Yeah, so what should we use with this actually? So entry would give us an entry if it's found. Yeah, or insert. Yeah. Yeah. So we would insert the default value there. So this would be the default for us, right? So yeah. So is it the better question to ask? Which one? What happens if there is no item? Okay. Yeah, if we don't have an item, or insert, yeah, default 0. Hash map entry. So the entry is what you're incrementing. The entry value is what you're incrementing here by 1. Yeah, in-place manipulation. Okay, this is not exactly what I had in mind when I was doing this, but yeah, and this you are okay. All right. So I think yeah, we can do the in-place manipulation. Yeah, by the way, this would then have to be mutable here. Yeah, and so what you were saying was entry or insert 0. Yeah. Or plus equals is what you were saying. But I think, yeah. Zero plus 1. That's the default there, yes. By the way, why is this? If it's not present or insert 1, yeah. But just if present n plus 1, yes. But what I'm looking at is this is the default, yes. And then when you find it, you need to increment the existing value by the other value, which is what you were saying, yeah, plus 1, yeah. But you can use a method for that, right? You don't have to do the in-place manipulation as we just did. Can we? What do I have here? No, I think I am already. Or insert returns immutable reference to the value. Right. But before I do that, I have the entry already. I can modify it, right? What happens if I do unmodify? It's a function. You already find an entry there. What happens if I do unmodify? Yeah, I can do unmodify actually. Well, you could do map entry. Yeah, exactly. So I don't think it is is what a map attribute that's used in here, usually in maybe Java or other languages they use it a lot. But yeah, I don't know what's common. I think I see a lot in the docs. Yeah, so we can do it plus equals 1, right? No, what does it say now? Yeah, I guess we need to dereference it, right? Mismatch. What's the problem? Let me see what you type here. Yeah, that's what we did. What's the problem? Mismatch type expected, unit type found, mutable reference. What is this? Map. Oh, we need to dereference map as well. Is that it? Wait. Is that what you mean? Wait, come on. No. No, just add a to the end of the line, you mean? Okay. All right. Okay. I think this is more this is clear, straightforward as well. Right. So unmodify would do it for us. And then we can then print what we have inside of we can then iterate over this now for item in map that you're now in your case it insets 1, increments the value. Yeah, so let's print this what we have in the as items of the map. Item does implement display traits. I think for that you can do, is it not? Oh wait, no. Is it not like so? No? Or is it the other way around? Don't remember. No, it's not right. No. Or maybe wait. Let's read it again. Problem is that string slice and i32 doesn't implement the display trait. Okay, yeah, so it's like this. Okay. Hello world, wonderful world. Yeah. Okay, that's not what we want. I think we want a 1 here. Right. Yeah. Okay. Nice. Yeah, I love collections actually. I think they're really cool. So in Java, for example, you have the collections framework is not great, and for you to do operations like fold and those kinds of things, you need to use var and stuff.
But I think in recent versions they started to add this gatherer API. I don't know if you maybe it's called the stream gatherer. Um, gatherer collection Java. Is it not gatherer something? Probably it's yeah, gatherers. So yeah, when I like how things are done in Rust for collections. Very straightforward. Yeah. Oh no, not Java string handling. Yes, yes. Um, don't give me that mess, please. Yeah, no, no. I quickly closed it. Okay. Yeah. So if we come back to yeah here. So I think yeah, I was looking at what to do with the hash map. Um, yeah, hashing functions by default. Yeah, let's zip hash, I think, as a default one. I mean, I don't think I would want to change this until I'm doing something that requires that. Yeah, and I think I'm done with hash map. Yep. So let's go back to the Rustling program. Oh, hash map now. I think that's probably here. Yep. All right. And what did they say we should do here? I think I should play music while doing this one. Hopefully it's not that bad. Okay. Yep. So a basket of fruits. The form. Small optimization. We don't need collect on line 4. Let's go back there. Line 4. Here. And then collect here. Because why? Okay. Why don't what then so split white space, what does this return? Remove the type from the variable. Okay. Alright. So we use the split white space, which is also, I mean, it implements iterator. Yeah, doesn't allocate an intermediate vector. Okay, it's loud. Yeah. Better? Yeah. Okay. Yeah, this doesn't, yeah. Still loud? Wow. Then we just turn it off. Still as loud as I think. Okay, then let's stop the music. Right, so but for this one, he said it's because it doesn't allocate. Yeah, an intermediate vector. Yeah, when you call the collect, okay, and then you just use that. Yep.
Okay. So the terminal operation would do that, right? And that would be, you can do inline iteration. Okay. So this, and I do for each, and then I dereference even on the hash map entry, and then I do, yeah. Will I? Okay. Yeah. Get for each, right? You don't like using it for each unless you really need. Uh, yeah. Exactly. I think if you're using docs.iter tools, you can just do that map the counts. Let me see this one. Right. I I like this. It's just that when I see this on on the map itself, it okay, yeah. I think it's just a bit new to me, like doing this directly here. Yeah, count only count numbers of splits. Right. Okay. Let's um do this directly. Okay. And then let's even see this thing for each. Say, oh yeah. Okay. Then you do the entry thing here. Yeah, that's exactly okay. That's this one. Okay. Um. Wait, where do you have the hash map? Yeah. Okay. Then you say map dot entry. I just call this 8, by the way. Of item. Sorry. Closure contains. Mhm. Yeah, I'm gonna try to fix it. There are many ways to do this if you remember footprint. Okay, let me try to fix this one first and see, as in make it into a one-liner. Yeah. Okay, so what is our problem now? So I'm doing a for each on this, and then I'm dereferencing the map, which you need to declare a map. Oh yeah. Yeah, that part. Mm-hmm. Yeah, okay. Right, unexpected token. Oh yeah, we need to put this like so. Oh no, it's mm. Use match types. Item entry item and modify this default one. I expected unit type found integer on what? Well, it doesn't say much. Maybe this. For each where does this end? Okay. Entry. Let me see what you had put here. For it's even that's even simpler. But again, okay. For each hash map the entry or insert. But why can't we do this that we have here? So how is this different? Entry or insert 0. So default will be, yeah, okay. Wait, I don't think these two programs are the same. For for each. When you do or instead default as 0, and you say plus equals 1, I need this piece explained a bit. No. We're saying use a default of 0, right? Come on. Oh, it happens after the or insert 0 returns. Looks up the entry, returns an entry occupied or either occupied or vacant, or insert 0. If vacant, insert 0, yes, which is what we expect, and returns meter reference item to that value. If occupied, returns meter reference to the existing value. Then this dereferences that and increments whatever value is there. Okay. Yeah, so it will always do this afterwards. Or it never leaves 0 in the map, yeah. It fires immediately after, making minimum value stored to 1. Yeah, this is why the commented out code is logically equivalent. Just makes 2 cases more explicit, relying on, yeah, more explicit, yeah. Okay. If we say yeah, okay. Exactly, yeah. Yeah, this is more expressive, I'll say. Like it's clearer what's going on. This is like, yeah, this does it, yeah. It's actually logically the same thing. It's going to do this and then this afterwards immediately. Yeah. It's basically, the map does not contain key. Yeah, the map that inside this, map that gets what's called, yeah. This is how you do it. Okay. So entry and modify. What is the difference here? When it says yeah, but when we tried to do it, it was, oh, okay, I see the difference. Yeah, it's, yeah, exactly. We'd have to put that in braces or parentheses, as it were, for each. We pipe this and then we do this. So maybe I say dot unmodify. No. Entry, yeah, and modify. Okay. I'll modify this. Insert. Why should insert be 0? Why should it ever be 0? Oh yeah, we need to close this. Here, right? Most likely I'm missing something. Yep, we have to. Unnecessary operation. Yeah, but does it do it? Yeah. Let's first see if this yeah, it does it. You don't need to deref. Don't need to deref no map. Right. That's the unnecessary deref I was talking about. Yeah. Okay. All right. I think I prefer this. it flows. Yeah. Okay. Nice. And then okay, yeah, we're done with that one. Let's then do this thing back here. So we have a basket of fruits in the form of a hash map. A basket of fruits in the form of a hash map needs to be defined. The key represents the name of the fruit, and the value represents how many of that particular fruit in the basket. We have to put at least 3 different types of fruits. For example, apple, banana, mango in the basket. And the total count of all the fruits should be at least 5. Okay, so we have a fruit basket, a function fruit basket that returns a hash map string and u32. So we should declare the hash map. Hash map new. Okay, yep. That's it, because when we do hash map or basket does insert, it already can infer the value from there, so we don't have to be explicit about it. So now what happens? 2 bananas are already given for you. Yeah. Okay. Put more fruits in the basket. So yeah. So we can put other things. To be honest, like some of these questions are not so they're so light, easy. We should just do this, like say apple, banana. Yeah, so I think we can say 3, yeah, 1, because he said at least 5. and then basket that is that. Yeah, I'll just give it mango. Wait, probably making yeah, mango, I guess. And then I can just say 1. What is wrong? Expect 2 arguments found 1. Insert. Oh yeah. So I need to return basket, yes, right? Yeah. Yep. But why are you still telling me you're expecting 2 arguments and you got 1? Is there a problem here? Okay, so that probably has a problem. What is it? Basket insert string. Oh, yep. See you. Yeah, thanks, ICS Boy X. Yeah. I also just followed you. Yeah, thanks. Yeah, it was nice, and thanks for the snippets that you sent as well. It's cool. Okay, so yeah, we have that. And then what should we do? I think, let's say the tests are just fruit basket, test the length, that's greater than or equal to 3. And then some other fruits. So that's like values. Some. That's how to do it, okay? And this is the, how's that thing called? Turbo fish operator, yeah. That's used here. And that's greater than or equal to 5. So wait 1 second. Yep. So now we just need to run this one. Like next. Oh, it failed. Fantastic. Or is it the same one? Hashmap 2. I think is the next one, right? Yeah, we are currently doing hashmap 1. So that was solved. So let's go to the next one. Okay, so we're collecting different fruits to make a delicious fruit cake. For this, we have a basket which will represent in the form of a hash map. The key represents the name of each fruit we collect, and the value represents how many of that particular fruit we have collected. 3 types of fruits, apple, mango, and lychee, are already in the basket's hash map. You must add fruit to the basket so that there is at least 1 of each kind and more than 11 in total. We have a lot of mouths to feed. You're not allowed to insert any more of the fruits that are already in the basket. Okay. Yeah. So don't add any ones that are already in the basket. Okay. So let's try to do that one. Okay. So for this now, we're using an enum, and we are implementing these attributes here. So we're doing comparison. So yeah, we have the fruit basket, which actually takes the basket, and then you are you're declaring fruit kinds, which is an array of the different kinds of fruits. You're iterating over fruit kinds, and then here you do the work. So we should insert new fruits if they are not already present in the basket. No, they are not allowed to put any type of fruits that's already present. Okay, so I think this is similar to what we just did already. We have an array. And we also have the hash map. So do we really need to do this inside of here? I don't think so, right? We can, why can't we do, I mean, we can say here, this would be the, is this about this example? I mean, this one we're trying to do? If yes, then I probably would write this, then look at this one. It's about this, right? So I can compare. I mean, like I can test my knowledge, about it. No, the count word. Okay, yeah. So you say it's the O and log version using sorting. Okay. What? Wait, let's look at this. Okay, so you have, oh, you actually write these implementations for it. I guess so it can run in the, using iter tools. Where does iter tools come from? It's a crate, right? Or is it in the standard library? It's a library. It's an external crate, right? It's actually using iter tools. Okay. Okay, but this is an external library. Yeah, that's what it looks like anyway. So let's go to what we have. We actually are doing this. So we have split white space. We're collecting this to a vector. Yeah. And then this is saying you should infer the type. And we're doing words that sort unstable. And the only reason, okay, sort unstable words. Why are we able to sort this? Is it because of this you had implemented here? Let's see. Run count is a struct. You're implementing iterator for run count. So when you do this, will it use? So when you're implementing the sorting yourself, that's what you're doing here. I mean, but when you do this, is it going to use the ones that are? Is it going to use this here? For example, like the iterator here. No, that's below the sort. Okay, as for this one, yeah. Okay, so just for the debug, right? Because I was wondering why. Okay. So sort unstable. See. On slice. So it sorts a slice in ascending order without preserving the initial order of elements. Okay, maybe we're gonna recall elements in place that it does not allocate. O and log n, worst case. If the implementation of ord for t doesn't implement the total order, function may panic. For example, a minus beta compared to a. Okay. Where is an example? Yeah. Okay. So why So you have a vector. I mean, you have a vector that has these, and then you sort them in ascending order. At least that's what we try to do here. Yeah, vec of words. Okay. And if we sort them equal one, ones are next to one another. Ha. Wait. Okay. We can just count on the runs of words. Ah, that's what you meant. Okay. I need to run this. Can I just copy everything here? No, I just have to do. Run on top left. Oh yeah, just right there. That's even easier. Right. So let's see this sort unstable again. So it does the comparison. May reorder equal elements. So basically, if elements are equal, wait, how do I even but this is what we have inside the no, you didn't print the vector. What you did is you did wrong count new words into iter collect vector, and this here is high values option count size, add a debug words on line 63. Okay. Okay, so what it did is the sorting actually, and okay, so but this solution here that you have, the idea is that we have a vec of words, and if we sort them equal ones are next to one another, we just count the runs of words. In terms of run count is just an iterator that counts the consecutive occurrences of the same element. Yeah, but in terms of so you get a new one, and then if it's there, some or none match. Yeah, just count it. Okay.
Yeah, this is okay. So your point is to provide another way to do this. So you count in the end. Yeah. Okay.
I mean, but I have the feeling that this is probably more. Um, I mean, in terms of performance, wouldn't the other one be more performance and even like simpler to implement? Because do we have this? Do we have this count right in the standard library, for example? Would we yeah, we should be able to count it. I mean, this would cause us to use. Wait, there was something you sent initially. You were talking about count, right? Is that what you meant that we should use? Let me go and see it. Yeah, you said we could do hello one forward or split that counts. Is what you said. Ah, that's what you said. If you're using iter tools, is that okay? Maybe that's the library thing. Yeah. So it is using much less memory. Well, that's the advantage of this. It isn't using the hash map. It is much less memory. Okay. So the iter tools create. So, but you mentioned about using iter tools, but we don't use it here. Or did you? Okay, you pulled this from iter tools, right? Is that it? You just had to put it here, so it's easier to follow, or because um we don't have to set up the environment for this. Is that it? Okay, okay, I see. Okay, so how can you show that this is using less memory than the hash map? I thought we had this compiler explorer from yesterday, right? Maybe we can put the two of them and see, right? Compilation failed. Ah, yeah. No assembly. The display. Well, pretty hard to see. You just measure max memory usage. Yeah. Okay. All right. I mean, it's cool to see that there is this other way to do it. I mean, I'm not so sure about the performance, but anyway, if something's small like this, should not really matter, right? And also, um, if it's a system where we are worried about memory, then maybe that can be a problem. But um, as long as it's uh, correct, then I think we're good with it. Yeah. But in general, the hash map needs to allocate a whole bunch of memory for all its buckets. Yeah. This just has a list of pointers to all the words. Right. Okay. So you have, yeah, first, yeah, you create the vector and then set unstable, you debug this, then you say last word and then count. So you go over the words that you have sorted, and then last word, if you are able to say this is I mean, if let's you are saying that if this returns for you some, and then last word is none here, last W, sorry, okay, yeah, so last word, if last W is word, increment it, otherwise increment this or return this. Okay. So your point is that and these are, what will be the type of this vector here is going to be um, a string slice, which internally is a string type, but it would be a string. So of course that is on the heap anyway. So, and that's also where the hash map will be. But your point is about the allocation. Okay. Okay. All right. Okay. Maybe we try to do this one. Yeah. Yeah. I would also look at eTurtles. I hadn't seen that one previously. Yeah. eTurtles just has counts built in, which is doing exactly what we did manually. Right. Okay. So coming to this example, to finish it, yeah, we I was saying that I don't think we need to use a for loop. We tried to do this before. All we need to do is to take the hash map, which is basket now, and try to put fruits into it that don't already exist. That's it. Insert new fruits if they don't already exist. And they told us about 3 types of fruits already in the basket. 3 types of fruits are already in the basket. How are they already in the basket? From where? Okay, from here. No, wait. How are those fruits already in the basket? What do you mean? 3 types of fruits are in the basket in the hash map. You must add fruits to the basket so that there's at least one of each kind and more than 11 in total. You know, I think you just need to look at the tests to write this thing, to modify this function. So we have apple, mango, and lychee, yeah. And okay, so it's always gonna call get fruit basket, I guess. This is a function here in the test. Yeah. So get fruit basket. Okay, it's always giving us these ones. I see. Okay, so that's why they say that there's already some in the basket. Okay. And we should just add what is not there, right? So we can say basket dot entry. Can we go from entry here, or we? Oh yeah. All right, see ya. I'm just gonna finish this one and go to bed as well. All right, thanks, Eustace, for stopping by. Yeah, yeah. Thank you. All right, bye. Yeah. Okay, so um, yeah. So we want to should we? How do we do this? Do we go from? I don't think we need to go from the uh, basket entry. We also need the we also need to iterate on the fruit kind, yeah, which is what we're doing there actually. So I guess we can go from fruit kinds. We need to iterate over this dot. I can map this. Yeah. Okay. Yeah, because we don't return anything. We're just gonna insert that's all. And now I can do basket dot entry. So um we get an item. Remember we're going through a particular fruit, and then we check the. Oh no! Why do I need to actually go through the entry? Can't I do? We can do contains, right? What does contains key do? Okay, so maybe I should do. Actually, we write that first, and if there's anything, we can change it. Yeah. So let's do entry again, like we did before. And then we can say um this is going to be fruit, right? Item. What is why don't I have access to it? Oh, sorry. Item entry, yeah. Dot yeah, we need to be able to maybe try to modify this thing. Yeah, but we're gonna so if we do entry and we found an entry, yeah, and this entry, by the way, what we need to do here is to compare, is to check that. Okay, let's see what we want to do. So we are going through the fruit kinds that we have, and then for each fruit kind, we check in the basket and see if it already exists. If it's there, we don't do anything. Otherwise, we add with the default count. That's what we do. Yeah. So now we have an entry. Actually, entry here should be fruit. Yeah, it should be fruit because that's the key there, right? So it should be fruit. And if we find one, yeah, if we find an entry there, then what we want to do is to ignore it, or we want to insert a default value of 3, I'd say. Yep, that's what we want to do here. Yeah, it's already a mutable. I mean, basket is already mutable, so it's fine. Mismatch types. Y fruits.ether. U32. Okay, I think that took. Wait, no, it didn't. Mismatch type expected. Wait a minute. So expected fruit found what reference to fruit. Oh yeah, okay. So we need to dereference that. And where is it? Is it, that's probably here. Oh, come on. Borrow of mood value. Fruit kinds are bird. Wait. Captured variable cannot escape. Function mute. Closure body. Map. Is it okay? Is it, no. not it. Cannot move out of fruit. Cannot move out of fruit which is behind a shared reference. Um, expected type fruit which is found refers to fruit. Yeah. I guess you can't do this. Are we using the wrong? Probably shouldn't use. Oh. How about into it there? Yeah. Unused map that must be used in the iterators that are lazy. Yeah, we didn't do anything with this actually, so we shouldn't use map. What should we use? If we don't use map, then should we use for each? For isn't for each, do we still need into iter? Why can't we do iter? No. Okay. I think I need to. Yeah, I need to go a bit soon. But yeah. Yeah, we're going to insert values here, but let's see what we get. Oh, it does. It solved it. That's it. That's what we needed to do actually. Okay, it was pretty simple. Okay, that's it. We do the rest of this and we'll continue tomorrow. Yeah. All right, then. Have a good evening. As you can see, I changed a few things. Put the chat there. Change where the video is. And yeah, we'll see how to improve. All right. See you.